Cool. So I'm going to talk about document deltas. They're not really document deltas. They're kind of tile deltas. So yeah. So from 2111 or all the way up to 2111, when you type, you end up with something like this, and your cursor is an overlay on top of the tiles. It's just drawn on top, and the rest of it are pixels. I mean, they look pretty ugly here because I've zoomed them in for you, but they're crisp and beautiful and grid aligned and all is well. And then when you type, an invalidation happens, and I'll show you the flow of that in a second. And we re-render some number of tiles that match that. And yeah, previously, when we, for example, hit enter at the beginning of the and here to shift this row down, we would essentially re-render and recompress the whole set of these tiles. So you'd end up with two new PNGs coming out for that. Obviously, if you move the cursor, that's an overlay. Nothing bad happens. Scroll up and down, pan, nothing rendered. Cursor blinking. Now that would be really stupid to render that on the server, obviously. So yeah, so now with deltas, instead of doing that, we start compressing in the time dimension. So obviously PNG compression compresses in space, if we've seen it before, it's pretty good at that. But time is really the dimension that counts, right? If you add a character on the end of here, only one little character changed, right? Not the whole thing. So you can get some really nice wins there. And so a delta in this case, just for putting this new line in, is essentially this. My tabs have gone west. You give you a C, which copies the span. So I'm going to tell you which bit to copy, and 12 rows, say, for the height of these pixels, and coming from here and going into here. So it's building from the previous one to a new one, and and then you need to terminate it because you could have multiple deltas. Yeah, and there's also like copy stuff from somewhere else. So like grab a bit from over here and move it here, which we don't use as much as we could. Anyway, so instead of having say 2K per tile, maybe 4K a change for doing this, we get it down to about 8 bytes. Well, maybe 16 bytes, one for each tile, which is good. And then we try and compress it, and of course it gets bigger. But never mind. Mostly when you compress things, they get smaller. But if they're sufficiently small, they get bigger. And I think, yeah, we could do something about that. And the PNG thing was quite verbose. There were PNG headers in there. We didn't put like metadata and photographer name and things like that, right? But there's quite a lot of framing and nonsense in there. And as it compressed, it would try different schemes to try and make it smaller, which was kind of slow. And in consequence, you would see like these 70% plus for PNG compression. So this is and writing rows and the zlib deflate stuff was a great chunk of the time. And to avoid this being a latency problem, we thread that piece. So we compress these things and we actually generate deltas in a threaded way. But actually this is a debug build. So there's loads of stupid stuff going on, Perco times and other stuff. So actually probably more than 70% in reality was PNG compression. So how did that work? Well, when you type something, your events come in from the browser to here, and this goes, oh, you changed something. So it tells WSD there's a change, and now we call that an invalidation. This area has changed. So then WSD has to choose what to do. In many cases, if that change is in your view area, instead of going, it's changed, and this guy saying, render it, and then doing the rendering, then sending it back, it goes, he's going to want to render that. So immediately the render comes back to here. So that then saves a lot of latency, because this latency can be 100 milliseconds or something round trip to the client on a very bad network. So that speeds it up. So we then start pushing tiles. Sometimes if we have pushed too many tiles and we're not getting responses saying got it, we would then fall back to telling the browser anyway, just to get flow control working nicely. So those who reinvent, who don't use TCP are doomed to reinvent it. But either way, we need to adapt to that thing, like a kind of buffer management mechanism. But typically we would push. But we're pushing quite big things. You remember like 2K, 4K tiles every time you can type characters. It's quite a lot of bandwidth. If you can be pushing something much smaller, life is very much simpler. Anyway. So another thing that happens from time to time is you re-render something that you've already rendered, because the invalidation logic is is conservative, meaning liberal. Like, that could have been wrong. You know, let's invalidate that anyway, just in case. Give you an example. You know, like you hit enter and you create a new page. But all of the fields in your documents might have been affected by that. They might be a page number, or they might be a count of pages. So let's just invalidate them all, you know? And I think Miklos did some nice fixes to go, wait a minute, you know, perhaps we could save on that. And of course, in a very long document, that's a very large number of regions to suddenly deal with. And I think Lubos has done some great work to try and, you know, reduce stupid invalidations and compress them and merge them. But anyway, but at the end of the day, you sometimes get the same thing rendered. And so we tried to deal with this by having a previous hash. So the browser would remember what thing it had, and when it asked for it, and the WSD would remember what the browser had, and it would say, oh, well, you know, can you render from this place? And then if it's the same, just don't send me anything. Which is kind of cool when you have one browser, or everybody is keeping up. But in terms of having lots of different people with different hashes, it's a little bit difficult. And hashes, of course, are not easy to compare. You know, they're a random number, and there's another one. Which one came first? Very hard to know. Similarly, we use these quotes spooky hash version 2, which is Ash's contribution. Thank you, Ash. Look at that. And how unique this is. I mean, it's a 32-bit number, right? You shouldn't collide very frequently, but you know, CRC32 is not the strongest form of uniqueness in the world, and yeah. So yeah, and of course we didn't send these numbers. We did send a wire ID, which kind of, well, anyway, gave you some ordering. So we'd only send it if it didn't match. So the new world in the Delta world is, of course, rather similar. You know, still the core tells us what changed, and then this can ask, and here we have a cache of all of the keyframes and deltas compressed. So they're like, I guess, like a PNG, and plus the changes on top. And then we can tell the kit, well, we need you to render something, and yeah, and we have. Actually, I don't think we sent the wire ID. Doesn't matter. We basically decide here now whether to make a delta or not, and we push that into the kit. And so we can force a keyframe. Obviously, there's no point in having a delta if we haven't kept the previous frame. It's really silly. So, yeah. So that's pretty cool. We don't do any hashing anymore because we can compare to the previous one, in theory. And we can at least do that fully reliably when we have that. So, making a delta is incredibly faster than PNG compression, which is good. It needs to be faster than Z standard compression, so we're raising the bar for ourselves. You know, like that's the thing. But of course, it's very much smaller. And then again, if you have a very large window on the client, it's a full screen 4K monitor or some such, you need to back that with memory so that you can compare the previous thing. So for big invalidations of big screens on, you know, whatever, we're talking quite a lot of RAM. So initially, we just did deltas around the area you're typing. Why not? So it's possible that we need to do a bit more work to make sure big invalidations don't happen, because it's slightly harder to keep the memory around to detect that. But we have some ideas there. There's also this wonderful unpremult copy thing. So for one reason and another, we render into a pre-multiplied alpha buffers. But unfortunately, all of the web standards, well, whilst underneath they're using pre-multiplied alpha, they pretend not to. So pre-multiplied alpha basically does the maths in advance so that alpha blending can be done much more easily. You save arithmetic during that. So we have to unpre-multiply it to send it on the wire. And yeah, we did some optimization there for long runs of the same pixel. Let's not do the same maths again and again. Yeah. And then, of course, there's the tile cache. So this guy here, instead of just storing one image, then has to store one image and a whole load of keyframes on the end. And so the nice thing about this is that now all of your browsers can be at different states with different places in this thing. And we have a monotonically increasing wire ID or, you know, like a time. And you can say, I want to play the video, you know, for this tile from this time. And you get something exactly right. And it's quite fun when you don't, because you start applying deltas to the wrong bits of the image, and you really see, you know, pretty quickly. It's like, you know, green squares, nothing. You know, it's really fun. So yeah, that works well, and it fixes a whole load of rare corner cases that used to bite us. And then, of course, we can decide when we generate a new keyframe, when we throw stuff away, and so on, when that seems sensible. So, yeah. Yeah. So it's generally a lot better. It should be a lot simpler. There should be no collisions. Slow clients. It's still not clear to me what to do about slow clients. Some clients are so slow that you don't. Well, so previously we would just shove data at them and then we'd stop at a certain point and wait for them to respond. Now I guess we can wait for them to respond, but we throw away keyframes when we get to a certain point, and then we just get a new one and build deltas on that. And so there's always something that we can send that represents that tile, bringing you up to date. That makes it hopefully easier. And of course, if you've got a low bandwidth client, it's a mobile phone on the end of some terrible internet connection, there's less data being sent, so the latency should be better and work better. So yeah. 75% low bandwidth. Of course, if your whole editing use case is holding down the period button, we can do better than that, right? Quite significantly better, or just hitting enter down a document. There are many ways that we can win a lot higher than that, and yeah, and some cases where we don't do as well. Yeah, well, I don't know. So and it also depends. Well, yeah. So the amount of bandwidth you use, anyway, we're lowering in our estimates. And the CPU cost too is nice. So code complexity reduction, CPU cost reduction, bandwidth reduction, useful. And there's more of this that we can do. So there are more gotchas in there. I was just profiling it just now and saw several things that. So I think there's at least another 2x there, and that we can get without too much hassle. And there's probably more we can do around reducing invalidations. So for example, at the moment, when someone new joins a document, we invalidate the whole thing. I don't know why. Maybe because of one of these historic problems that we had, and someone was like, it's too complicated, just, invalidate world. And that's kind of expensive for all of the users. So we should probably look into those things. But hey, it worked pretty well before we did all this, and now, so anyway. It's just a need-based thing. And yeah, I guess it's shipping. So just use it. And, there are many things like, Quickie doing data tables or whatever that you can see something beautiful at the end of it. And you're just going to have to believe me. There's all these funky complexity inside because it looks just the same. So hopefully it feels better. And here's some more things. So I think we should do some more profiling. I mentioned the size of the cache that we keep in the kit process to build deltas with. We should orally compress that. There is lots of white lines of nothing in documents. So that would reduce the tile cache size and mean we can store more of it and do more. I mentioned the Z standard dictionary compression earlier. Yeah. What does the last thing mean? Intelligent region merge and render. It sounds good, doesn't it? Oh, yes, perfect. So at the moment we render a whole tile when we get an invalidation, but we often know just the bit that changed. It's very small. And so we should be able to just re-render that bit, and the rest of it, that's just going to be what it was before, right? So then we only have to build a delta for a very small piece. Less memory to fiddle with, less to draw, less to delta, and then perhaps we can do better at comparisons. Yeah. So yeah, in the JavaScript side, JavaScript is a little bit finicky. The code to actually upload stuff to the GPU or push textures is pretty nasty. Anyway, it likes a uint8 clamped array, and we could decompress directly into that type instead of a uint8 array, which doesn't have clamped in it. So there you go. Hopefully they wrap around the same thing, and it's optimized in most browsers, but you never know. And yeah, so currently we don't bother to detect horizontal changes, which is another very large use case. You insert a character here and all this moves that way, or you delete a character and it all moves back. And yeah, we could easily do a lot better with that, I would argue. And it's there in the protocol. It's just, we just need to do it. So we can shrink, I think, bandwidth use again by some nice factor. And we have unit tests, so the protocol and the deltas are all written nicely and have C++ unit tests as well as JavaScript implementation. Just, yeah, kind of good. What else? Yeah, I forgot to mention that one of the things that we used to do is that if you got 2 or 3 tiles, we would decompress them and push them one after another. And now we essentially decompress, and instead of pushing to the GPU or the canvas and back again and fetching it again and changing it and pushing and fetching it. We just do a single whole stream of updates and push it, which should make the client more responsive too. So that was it pretty much. Thank you.